Welcome class, myself Professor D. S. Rai, Professor, Department of Civil Engineering, BBDITM, Lucknow. Today we will take up course KCE 076 Urban Transportation Planning. Today lecture is 33, in which we will discuss evaluation of transport planning proposal. References I have taken Chakravarti Partha and Das Animes, Principle of Transportation Engineering. Second, Pepe Costa, CS and Prevendes, PD, Transportation Engineering and Planning. Kadiali, LR and Lal, NV, Principle and Practices of Highway Engineering. R. Srinivas Kumar, Introduction to Traffic Engineering. Some material have been taken from NAPTEL and some material have been taken from internet. The contents today we will cover evaluation based on multiple criteria. Second, rating and ranking. Next is cost effectiveness. Next is evaluation of completed projects. Next, evaluating effect of transportation on social and natural systems. So, we will take up one by one. First is evaluation based on multiple criteria. Many problems associated with economic method limit their usefulness. Among these are converting criteria value directly into dollar amount or rupees amount. Second, choosing the appropriate value of interest rate and service life. The next is distinguishing between the user groups that benefit from a project and those that may lose. Evaluation is the process by which we can determine which project or which alternatives are better than others. Finally, we can choose one of them, but there are many criteria for selection of the alternatives. Suppose if we are talking about the Lucknow, nowadays Kisan Path is under construction. There are many alternatives of Kisan Path. That includes construction cost, that includes land cost, compensation of lands, comforts to the passenger or users, and of course, environmental impact. Presently, Kisan Path is on outer periphery of the Lucknow. It is covering some part of other district also. Choosing all parameters like initial cost, interest rate, comfort, service life, annual expenditure, comfort of course to the passenger, and door to door services from the roads, because the Kisan Path is nowadays under construction is on the outer periphery of the Lucknow. In future, after sometimes 5 years or 10 years, this will come under the city. So, the today or even 2 years or 3 years, we have to make such arrangement that people will get services to their doors. This is the idea of evaluation of the project or alternatives. Each project or each alternatives have certain advantage and certain disadvantage. Considering these all factors, then the evaluation has been done considering multiple criteria, and then finally, we choose one of them. So, now we can proceed. The failing to distinguish between groups that benefit and those that lose. Considering all cost, including external cost also. This cost may include depreciation also. The discusses evaluation method that seek to include measurable criteria that are not translated just in monetary terms. The main things of evaluation is rating and ranking of the alternatives or the project, because this is one of the tool by which we can say this project or this alternative is better than that one. So, the numerical score are helpful in comparing the relative worth of alternatives in cases where the criteria value cannot be transferred into the monetary amount. So, this could be written as S I is equal to sum over j is equal to 1 to n k j v I j, in which S I the total value of a score of alternative I, K j weight placed on criteria j, V I j the relative value achieved by criteria j for alternative I. The application of this method is illustrated by the following example. This example have been taken from internet, and the example is from USA. For understanding point of view, that has been taken from the internet. So, we have taken evaluating light rail transit alternatives using rating and ranking method. A transportation agency is considering the construction of a light rail transit line from the center of the town to a growing suburban areas or a region. The transit agency wishes to examine 5 alternatives alignment, each of which has advantage and disadvantage. In terms of cost, ridership and service provided. The alternatives differs in the length of line, location, type of vehicles used, seating arrangement, operating speed, number of stoppages, estimated value achieved by each criteria for each of the 5 alternatives are shown in the table. This is the table. The agency wants to evaluate each alternative using a ranking process. Determine which projects should be selected. So, we can see in the table, this is the number 1, 2, 3, 4, the measure of effectiveness. How effective the each item we can say. First is a annual return on investment in percentage. How much amount will be returned? And here there are 5 alternatives. In alternatives 1 we can see here 13.0, second 14.0, third 11.0, fourth 13.5 and fifth 15.0. So, the annual return percentage is maximum in alternative 5. Likewise, the daily ridership in 1000, and we can see here in alternative 1 that is 25, alternative 2 23, alternative 3 20, alternative 4 18 and alternative 5th that is 17. So, here as per ridership, alternative first is supposed to be the better. Now, come to the next one, that is a passenger seated in peak hour in percentage. So, here the alternative 1 has 25, 2 has 35, third 40, fourth 50 and fifth 50. So, we can see 50 is the number of passengers seated in a peak hour. The next is length of line in mile. In alternative 1 we can see here that is 8 kilometer, 8 miles sorry, alternative 2 7, alternative 3 6, alternative 4 5 and alternative 5 5 miles. So, this is the table of in which the advantage and disadvantage of alternatives are given. So, now come to the solution. What would be the solution? The first step first is identify goal and objective of the project. This is the top priority works. The transit agency has determined that the 5 major objectives should be achieved by the new transit line. And what are the objective? they are net revenue generated by fare should be as large as possible, and this is the objective of any transportation system. Whatever the revenue generated in an alternative, that should be a maximum and that should be larger. This is our main motive or objective of any transportation system. Second, ridership on the transit line should be maximized. Ridership should be more. One of the example I am giving you, Lucknow Metro. Lucknow Metro is going in loss. Why? The ridership is not increasing as it was expected. So, the total project is going in loss. The next is service on the system should be comfortable and convenient. In cost wise, it is not measurable, but it is one of the things which are considered while taking a alternative or selecting a alternative, because comfort and convenience is one of the main issue of the user, transportation user. The next is the transit line should be extended as far as possible to promote development and accessibility. The transit line should be such that it contribute in development of the city, urban area, but there should be accessibility also for that transit line. The next is, that is the fifth objective, is transit line should divert as many auto users as possible during the peak hours in order to reduce the highway congestion. So, means the passenger or the road user should be diverted when there is a peak hour and to avoid or to reduce the congestion on the highway. So, these are the 5 objectives on which the alternatives are evaluated. Now, come to the second step, develop the alternative that will be tested. In this case, 5 alternatives have been identified as feasible candidates. These vary in length from 5 to 8 miles, the alignment, the amount of the system below, at and above the grade, vehicle size, headway, number of trains and other physical and operational features of the line are determined in these steps. So, this is a physical things that will happen, should be considered or fixed or determined in this step. Now, come to the third one, the define the appropriate measure of effectiveness for each objective. We have 5 objectives and each objective should be appropriate measure of effectiveness. For the objective listed in step 1, the following measures of effectiveness are selected. So, we can see in the table these are the objective 1, 2, 3, 4, 5 and the measure of effectiveness here is net annual revenue divided by annual. Second, capital cost. Third, total daily ridership. The next is percent of rider seated during the peak hour. The next is miles of extension into the corridor, and the last, number of auto driver diverted to transit during the congestion period or peak hour. The next step is step 4. Determine the relative weight for each objective. This step requires a subjective judgment on the part of the group making the evaluation and will vary among individuals and vested interest. One approach is to allocate the weight on a 100-point scale. This is the allocation process, just as would be done in developing final grade average of a course. Another approach is to rank each objective in order of importance and then use a formula of proportionality to obtain the relative weight. In this example, the objectives are ranked as shown in table. The weighing factor is determined by assigning the value n to the highest ranked alternative, n minus 1 to the next highest, and so forth, and computing a relative weight as. By this formula, we can say K j is equal to W j divided by sum over j is equal to 1 to n W j, where K j is a weight factor of objective j, W j is the relative weight of objective j. So, we can see here these are the objective ranking, relative weight and weighing factors. So, we can see here the ranking is 1, relative weight 5 and weighing factor is 30. So, we can see here this is the relative factors. Now, come to the step 5, determine the value of each measure of effectiveness. In this step, the measures of effectiveness are calculated for each alternatives, and so the cost estimate are developed based on the length of the line, number of the vehicles and station, right of way cost, electrification and so forth. Revenue are computed and the ridership volume during the peak hour are estimated. In some instance, forecasts are difficult to make, so a best or most likely estimate is produced, since it is a comparative performance of each alternative that is of interest. Relative value of effectiveness measures can be used. Then come to the step 6, compute a score and ranking of each alternative. This score for each alternative is computed by considering each measure of effectiveness and awarding the maximum score of the alternative with the highest value and appropriate amount of alternative. Consider the first criteria, return on investment. Table shows the alternative fifth achieve the highest value and awarded 30 points. The value for the alternative First is calculated as 13 by 15 into 30, that is 26. The result are shown in the table. So, the total point score indicates that the ranking of the alternative in order to preference is first, second, fifth, fourth and third. Alternative first and second are closely superior to the others and are very similar in ranking. These two will bear further investigation prior to making a decision. So, in this table we can see the major effectiveness 1 to 5 total has been given here. The alternative 1 87.5, second 87.2, third alternative 74.5, vast difference. Then alternative 4 77, it is similar to the alternative 3, and the fifth, that is 79. So, the first and second is neck to neck. The cost effectiveness attempt to comprehensive in approach while using the best attribute of economic condition. The project criteria are considered to be the measure of the effectiveness. The cost are considered as the investment required if the effectiveness value is to be achieved. The data from the economic analysis is used positive measured environmental consequences. And so, this is the example of evaluating metropolitan transportation plans during cost using cost effectiveness. The solution is given here. The examination of table yields a several observations in terms of number of transit passenger carried. Plan E ranks highest, followed by plan B. The relationship between the annual cost and the transit passenger carried is illustrated in the figure. The cost effectiveness analysis indicates the plan B produce a significant increase in transit passenger over plan A, although plan C and D and E are much more costly. They do not produce any more transit rides for the added investment. So, we can see here this is the cost effectiveness here mentioned in the table, where the person displays, the business displays, annual total fatal accident, annual total personal injuries, daily emission of carbon monoxide, daily emission of hydrocarbons, average door to door auto trip speed, average door to door transit trips, annual transit passengers in millions, total annual cost, interest rate, that are given in the table. And this is the graph between the annual cost to the passenger carried in the millions, and we can see here the cost is increasing, just a few numbers increases, the cost is increases like this way. Then the this is the passenger in the millions and the business displays, it is shown here. The next is hydrocarbons emission, annual cost is given here, and we can see here this is the cost is much higher when the emission hydrocarbons emission is higher. So, cost effectiveness we can say in terms of the business displays versus transit passenger carried, plan C and D requires considerable disruption with the very little increase in the transit boundaries over the plan B. So, evaluation, so we can go for the evaluation of completed project to compare the alternatives. So, we can see here how effective it has been accomplished its objective, or what can be learned that is useful for the other project decision, and what changes should be made to improve the current situation if the project should be continued or abandoned. So, example is given here, and evaluation, we can go for the evaluation of the completed project for comparing the alternatives we are considering. So, these are the example given here. So, thank you very much. Thank you.